Here we have what looks like a pretty straightforward question. So go ahead and press pause and work through this on your own, and then press play and we'll go through it together. Okay, so probably most of you solve this the way that an average Joe would, which is to say, you might say something like, I put my y equals 0 at the ground. Remember, because you get to choose where to put your y equals 0. And if you put your y equals 0 at the ground, the y position of the ball is 5 meters. So maybe you were envisioning something like this, where here's the ground. That's where you're putting your y equals 0, so there's your origin. And if that's your y equals 0, then at the position y equals 5 meters is the location of the ball. And then I can calculate the potential energy due to gravity as just mg times y. So that'll be 2 times 9.8, and y is equal to 5 meters. So you get 98 joules. Now, this is fine. This answer is perfectly correct. There's nothing wrong with this. Somebody else might say, I can put my y equals 0 anywhere I want, which is true. You can put your y equals 0 anywhere you want. You can put the origin of your coordinate system anywhere you want. Physics should not depend on where you happen to choose to put your origin. So Edgy Jane decides, because she can put it anywhere she wants, she's going to put her y equals 0 position at the location of the ball. Okay, so here's the ground down here. Here is her y equals 0. So this is the origin of her coordinate system. It's right here. And in that case, the y position of the ball for her coordinate system is 0. So according to Jane, she would say the ball has 0 joules of potential energy. And we now have to ask ourselves, who is correct? Well, it should not matter where you put your y equals 0. So we cannot say that Joe is right and Jane is wrong. We have to say they both are right. The problem is they're both saying different things. Okay, so what we're going to find is, it's never interesting to us to just say how much potential energy does something have in that position. That's not going to be interesting because that is relative to where you put your y equals 0. What will matter, though, is how your y position changes. Okay, so this is definitely the way we calculate what is our potential energy. But this, and we have to acknowledge, this does depend on where you put your y equals 0, because this value of y will depend on where you put your y equals 0. Luckily, what really matters is your change in potential energy, because the equations that we use, they always have like a u initial on one side of the equation and a u final on the other side of the equation. So really what matters is how does the potential energy of the object change. And to answer that question, it does not matter where your y equals 0 is. So what really matters is delta u. How does that value change? Okay. So for example, if we were asking the question, what's the speed of the ball when it reaches the ground? Someone who puts their y equals 0 at the ground, that's fine, because they would say initially the potential energy of the ball is m times g times 5. And the final potential energy of the ball is 0. Someone who puts their y equals 0 here would say that their initial potential energy of the ball is 0, and the final potential energy of their ball would be m times g times negative 5. So in the end, both of these systems are describing that the ball has lost the same amount of potential energy. Okay, because y final minus y initial is negative 5 for both of these people. So they both would say the ball has lost the same amount of potential energy. So this is just pointing out it's okay. Don't worry about where you put your y equals 0. Just keep it consistent.